Hello everyone, welcome back to my channel. In this video we're going to be discussing the graphical derivation of demand curves. Right, so graphical derivation of demand curves. So in the last video, or a set of videos really, we discussed how to derive demand functions given the consumption optimality condition, where MRS is equal to MRT. If you want more information on that, watch those videos. In this one, we want to see how to derive that demand curve that we're used to, P and X or Q, really, quantity, and for a particular good. In this case, for good X. So let's get started. So coming in, we know that, we should know, and if you don't, that's okay, now you do. A change in a price. Before I go on, remember, if you're an experienced member of my channel, thank you. You know that I do write out notes quite often, and that's so that we can hit our different learning styles, right? Activate our brain as we learn here. So you see it, right? You read it, and hopefully you're writing it as well. You see it, read it, hear it, and hopefully you're writing it as well. All right, so we have that a change in a price causes the budget line to rotate so that the consumer chooses a new optimal bundle. Right? Certain key terms in here. One of them is budget line, and we did underline price and new. The other is optimal bundle. So what are we talking about here? Well, we're talking about our consumer constraint choice, right? So we have Q, quantity of Y, quantity of X, and there's this budget line basically telling us what the consumer can afford. Where at this point, if everything that the consumer earns is being spent on good Y, this is what they can buy. If everything the consumer can afford is being spent on good X, this is what they will buy, and everything else in between that they can afford. And we have the indifference curve that just touches our budget line, or budget constraint, is the optimal bundle, because it's the indifference curve that gives the consumer as much happiness as possible that they can actually afford. Okay, so let's say some more words here. To draw the demand curve, we determine how the quantity demanded changes as price changes. Right. This should be very familiar to you, because that is literally the definition of a demand curve, right? How changes in price affects changes in quantity demanded. Okay, so let's consider certain things. In the previous video, with the utility function, so you consider /suppose. Yeah, it's like, which one do you use? All right, the utility function was Q of X to the power of 0.5, Q of Y to the power of 0.5. We had our budget line or budget constraint. This was income is equal to, remember we just used I for income, is equal to the price of good X times the quantity of good X purchased plus price of good Y times the quantity of good Y purchased. Now, using using these two pieces of information, we found that our optimal, with the optimality condition, MRS is equal to MRT, we found that the demand function for x, good x, was equal to I over 2 P of x, and the demand function for good y was equal to I over 2 P of y. Okay, so we have those two equations, but we want to go a little further, deeper and visual with this demand curve. All right, so now suppose that we have certain information that income here is equal to 100, the price of good y is equal to 2, and the price of good x is equal to 5. We also have that the price of good x could be equal to 4, price of good x equal to 3. Now at this point, we see that the price that's changing is the price of good x, which implies that we want to draw the demand curve, for good x. So remember, the demand shows us how quantity demanded of good x changes as P of x changes. Right, so that means that everything else is held constant. We're going to keep I and P of y, income and price of good y, constant. Okay, so what does that mean for us here? Very quickly, since we already know the equation, we could just say, oh, well, we know the equation for, demand function for good x. This would just be, this is income, so this would just be, right, that 100, so Q of x here at point A will just be 100 divided by 2 times, but let's use parentheses since we have x's everywhere, 2 times 5, right, if the price is 5, which is, 10. So 100 divided by 10. So we'll call this point A. Point A. At point A, Q of x is equal to 10. At point B, let's call this point B, we'll have that Q of x will be equal to 100. Remember, we're keeping income and price of good y fixed. So we have 100 divided by 2 times, and P of x in this case is 4. Now, this 2 here is from our function, demand function that we derived in the previous video. It's not this price of y. Okay, so from that, we have that for point B, Q of x to be equal to 12.5. So the optimal choice for this person, who was Rory in our last video, the optimal consumption for Rory when the price of good x is $4 is to consume 12.5 units of this good. All right, so let's do one more. This is point C. Right, for point C, we have that Q of x will be equal to 100 divided by 2 times. You should know what number goes in here at this point. If you thought 3, you would be correct. Right, that's the price at point C, and this will end up being 16 2 thirds, or 16.67. Okay, so we have this information. You could say, well, why don't we just go ahead and plot this, right? If we have P and Q and we're like, oh, this is P5 and so on, and we can plot that. Absolutely. But that would kind of be like plotting from our equation. We want to do a graphical derivation here. So what we're going to do visually in very, very soon is see those optimal points. Let's change the color back to blue. Right, we want the optimal points for the various prices graphically, and then we're going to transfer them graphically to a demand plot. All right, so let's go ahead and get started on that. Oh, it's absolutely doable. We'll be doing this together. Teamwork, yes, makes the dream work. All right, so first things first, we're going to draw the constrained consumption plot area. So we have, I try to draw as big as possible. Okay, so quantity y on the vertical and quantity x on the horizontal. Horizontal, flat like the horizon, like what you see when you look at the horizon. Okay, so let's draw this. Remember, let's put some quick information here. We said that P of Y is equal to 2, income is equal to 100, and we have 3 different choices or points for P of X. There's 5, 4, and 3. Okay, so let's start with 5. So we want to draw our budget line. So we say that Rory has $100 to spend on good X and good Y. Right, so if she's spending all of her $100 on good Y, then how many units of good Y can she afford? What we're trying to do here is determine our endpoints for the curve, and then we're just going to connect them with a straight line. All right, so we have, or intercepts with our, okay, we have $100, and if the price of 1 unit is 2, then we would say 100 divided by 2. And Rory would be able to afford 50 units of good Y if she spent all her money on good Y. Now, we can do the same thing over here for good X. So if Rory spends all her money on good X at that price of $5, then Rory will be able to get what? Exactly 20, so that's 20 units. So because we know that the price is decreasing as we go on, it means that she'll be able to afford more, right? She has the same amount of money, but the price is now cheaper, which means she can buy more of the stuff. We're going to put 20 somewhere closer to 0, so we'll have more space to draw as we go on. So we have here, this is 20. Okay, so we can connect these two. We say that at the price point of 2 and 5 for good Y and good X respectively, Rory's budget line will look like this, given that she has $100. Okay, and then we have our utility function. Actually, before, yeah, okay, let's draw it, why not? We have our utility function in difference curve. Remember, it shows us the combination of good Y and good X that gives Rory equal satisfaction. So let's draw something that looks like this. So we'll call this ICA. In difference curve A, we'll call this budget line or budget constraint A. And we see here that this is the point of tangency. So this is point A, right? At point A, we know that Rory is going to consume how many units? Well, we already did that math, and we saw it was 10 units. 10. Okay. If we didn't already have that equation, we would have to go ahead and do the constraint calculation, where we would set MRS equal to MRT for the specific numbers of where P of X over P of Y, where P of X is equal to 5 and P of Y will be equal to 2. And as we go on, we keep changing P of X in that equation. But because we derived that earlier, we have saved ourselves some calculation here. Okay. So next we have a new budget line when the price is $4. So we go through the same process. Now, notice that the price that changes is the price of good X. The price of good Y stays the same. So Rory, if she was spending all her money on good Y, would still purchase 50. But if she was spending all her money on good X, she would be able to purchase now 100 divided by 4, which in this case is 25, right? So 10 is so far from 20, but we will rescale, that's fine. 25, so we want to connect those two lines or those 2 points there to make a line. And we go. My drawing skills could be better. No, but that's okay. I forgive myself. I just need to undo something here. Bear with me. Oh, it's not letting me. That's upsetting. But again, it's okay. We will just redraw. You cannot beat us. That's right. Technology. We refuse to be defeated. Okay. Nice. All right, so where were we? Thanks for your patience there. So here we have 25, right? Now, things to note, this budget line has tilted out, rotated out. Remember in the introduction, we talked about how this happens, right? When the price changes, the budget line will rotate. Right, so we can find our new optimal bundle. We're seeing that happen here. Okay, so we need a new optimal bundle because neither of these points will make Rory as happy as she can be. She can afford them, that's great, right? But it's not good enough. But she can find a higher indifference curve that will make her even happier. So let's find one here for Rory. And we'll call this indifference curve B. And this is point B. Okay. At point B, we know that Rory's consumption is 12.5. Okay. We have one more. Point C for the $3. When the price of the good is now $3, we know that Rory is going to be able to afford even more stuff, but we want to know exactly how much more. So if she's spending all her money on good X and the price is now $3, then she can afford 33 1/3 units of the good. So this would be for good X. Sorry, yep, good X. And for good Y, remember the price doesn't change, so it's still just going to be $50, 50 units there. So we need 33.3333, which means that our budget line is going to rotate out. I'm just going to draw this to the best of my abilities here. We are not all artists. That's okay. We're just trying to get some information, understand what's going on here in this process. Okay, so I'm not going to erase that. We know what happened last time. This is 33 to the third. This is the new budget line that Rory would be facing. And again, she could afford these combinations of the goods, but we know Rory is going to want to maximize her happiness. So she's going to look for a utility, an indifference curve that is even further out, that will make her even happier, that she can afford. So let's draw what that indifference curve will be. And we'll call this I, C, C. And then this is point I'm so afraid to erase these days because yep, something like that could happen. But it's important. Okay. I see 3. What I'm trying to do here with the indifference curve is make sure that they don't intersect. They should be the same shape, and they just keep increasing away from the origin. They keep increasing away from the origin. Same shape there, not an L, but a curve. And we call this point C. Right. This is an optimality for the new budget line. So at point C, we know that Rory's consumption is going to be 16 2/3. Okay. So from this information, we can trace this down to a new curve. Let me make this a little smaller so we can see this happening on the same page. Okay. So we're going to trace this down. And so we can draw our demand curve that we are graphically deriving. Life is good. So now we have 10. And this is 10. This is 12.5. This is 16.67 or 16 2/3. Let's draw this new area. What are the two variables in our demand function? Yes, price and quantity. Price goes here on the y-axis, Q goes here on the x-axis. All right, so we know our quantities there, right? Because of our optimality condition above, we already have that information. What we need now are the prices, but again, we have that information, right? So we have, let's start with 5 actually, that at the quantity of 10, price will be 5. So that means the highest point there, right? So 5 intersecting with the quantity, this would be point A. True? You see that? Remember, point A is a point of price of 5, quantity of 10. And then we have point B, price of 4, quantity of 12.5. So 4 will be here. Quantity 12.5, call this point B, right? Price of 3, what's this? Quantity of 16.23, right? So we see here that on this demand curve, Rory is optimizing her consumption. She's choosing based on her optimality, optimizing her happiness, given her budget constraint. Okay. You notice that this is very specific to Rory, first of all, and to her income level. This is an intermediate level of understanding. You can imagine how much more complicated this will be if we want to find this for any income level for the whole market. Right? But understanding how the demand curve is derived for even one person, having that base understanding is important, and it will guide your understanding as we go through the rest of the courses in economics, especially micro. All right, so we're going to connect to these 3 points here with the line. Remember our demand equation for QX was equal to I over 2P of X. What that means, which we have, right, for any income level. Isn't that wonderful? But visually, we need to lock certain things down. All right, so for this equation, as price of X increases, this number will approach the axis asymptotically. So it's just gonna keep going that way and up there. And this is our demand function. But honestly, connecting those 3 points, A, B, and C here, is a great achievement. Right? If that's as far as you can get, that is a great achievement. Demand function for what good is this? Good X or good Y? Yep, good X. Right, so this is the demand function for good X. All right. One more thing to mention, since we've drawn this out here, is the price consumption line. Right, the price consumption line here shows the price consumption line shows that the consumer's consumption of both goods, come on, bear with me, my computer's fritzing. Good, okay. Both goods increases as the price of X falls. Right? Once that comes back, we'll write it down. Holding the price of good Y constant and income constant. And we see here that it's true. As we go from A to B, we're increasing both quantity Y and quantity X. And from B to C, we're increasing both quantity Y and quantity X. Right? So this line that connects points A, B, and C is our price consumption line. Let's try this again. Still not working. That's okay. Maybe we'll do this in a different video. But hopefully at this point you have seen how to graphically derive a demand function, right? And we did this from the optimal bundle choices that the consumer will pick as the price changes, and that price change affects the budget line. It should tilt them either out or in if you're going in either direction. Notice that we held the price of the other good constant, and we also held the income constant. All right, if you have any questions about this, feel free to send me an email or put it in the chat. Okay, bye. We will just wrap this up here.